Let's look at section 2.4, more on the concept of the slope that we were looking at earlier in 2.3. We've got three learning objectives here: finding slopes and equations of parallel and perpendicular lines, slopes as rates of change, and a function's average rate of change. We still need to recall the formulas that were given on the 2.3 note sheet, along with this information about slopes of parallel and perpendicular lines. Just recalling that parallel lines have the same slope, perpendicular lines have slopes that are negative reciprocals, and just recalling what that means. If I have one line that has a slope of 1/2, then the perpendicular line to that will have a slope that is its reciprocal 2/1, but opposite in sign, -2/1. So those are considered negative reciprocals, opposite in sign, and one is the reciprocal of the other. Recalling the slope formula, y2 minus y1 over x2 minus x1, interpreted as rise over run, and it's also called change in y over the change in x, and the average rate of change of a function. When we get to it, we'll go ahead and recall that formula as we need it. So let's get started. Let's look at this situation where we're going to look at some more concepts of slope. We're given two lines here. This line is L1. This line is y equal -2x. What we want to do is write an equation for this line, L1, in the two forms that we talked about, given that the two lines are parallel. Well, parallel tells me something. If I look right above, parallel lines have the same slope. How can I use that? Well, I'm trying to find an equation of a line. And to find an equation of a line, I need, as we did in the previous section, I need a point and a slope. If I'm trying to find L1, which is here, I'm given a point, 3, 4, it's right there. Oops. That's not what I want. Oh, it's over here. 3, 4. There's my point, 3, 4. Then I can use my slope-intercept form, my point-slope form, to find the equation of a line, because I have a point, which is 3, 4. I have a slope. Well, do I really have a slope? Well, I know that my line is parallel to this one, and this line has a slope which can be taken from that part right there. The slope of this line is -2. Well, if the slope of this line is -2, then the slope of this line is going to have to be -2 as well, since they're parallel. Well, let's look at the information we have now. We have a m equal -2, and we have a point of 3, 4. That's all we need to do y minus y1 equal m times x minus x1. Y minus y1 is going to be y minus 4. M will be -2 times x minus x1, which will be x minus 3. Have a point, we have a slope, we use the point-slope form. Y minus 4 equal m times x minus 3. And we can clean that up. It's just y minus 4 equal -2x plus 6. And if we wanted to transfer the 4 on the other side, if we wanted to add 4, we'll get y equal -2x plus 10. The two forms for the equation of a line. So using the fact that parallel lines have the same slope, and so they gave me the slope of the line it was parallel to, so I just had to use it. What if the problem didn't say, given that the lines are parallel? What if it said, given that the lines are perpendicular? If the slope of one line was a -2, what would be the perpendicular slope? Well, remember, we defined it as negative reciprocals. So for a slope of -2, its reciprocal would be 1/2, but it would be a positive 1/2 because they are opposite in sign. These two numbers should always multiply out to give you -1. That's how you know if you got the right reciprocal. So let's look at this one. We have some conditions to write an equation for the line in both point-slope form and slope-intercept form. Well, we have our point. We have an x1, y1. So I can get started with y minus y1 equal m times x minus x1, but I'm missing a piece. I'm missing the slope. So here's what they tell me. They tell me the line I want is perpendicular to this line. Well, what's the slope of this line? There it is right there. M is equal to 1/3. The slope of that line is 1/3. But the line I want is perpendicular to that one. So if this line has a slope of 1/3, what's going to be the perpendicular slope I need to use? The negative reciprocal. The negative reciprocal of 1/3 is a -3/1, or you could just call it a -3. There's the slope that we need to put in our equation. Let's go ahead and fill out our information. Y minus y1 is going to be y minus 2 equal m, which is -3, times x minus x1, which will be x minus a -4. Cleaning this up, y minus 2 is equal to -3 times x plus 4, taking care of that double negative. So there's one form. The other form is we can distribute and clean this up. Y minus 2 is equal to -3x minus 12. Y is equal to -3x, add the 12, minus 10. So two forms for the equation of the line. They both say the same thing, just two different forms. But we had to go and look at and rely on our facts about perpendicular lines who have slopes that are negative reciprocals of each other. This line had a slope of 1/3. His negative reciprocal was a -3/1. Using that point, or I should say that slope, and this point, we were able to find the equation of that line.